Question 12 is very much a question of two halves, with a fairly straightforward part A and a pretty tricky part B. So in the first instance, we've got this cylinder with a radius of 8 centimeters. It's placed on a flat surface filled with water to a height of 12 centimeters, and we're asked to find the volume of water in the container. So this is intuitively, or using the formula, the volume of this is going to be it's the same for a prism, the cross-sectional area times the height. So the cross-sectional area of the base is going to be pi r squared, and we're going to multiply it by the height. So bear in mind the radius is 8, that's going to be pi times 64 times 12, which is going to give us 768 pi, or we can convert that to 2,410 centimeters cubed. Before we tackle the maths behind part B, it's important here to try and figure out what is actually going on. So we have got a heavy ball with a radius of 2.9 centimeters, which is dropped into the container. So you want to think about what's going to happen. Effectively, this sphere is going to be dropped into the water, and what's going to happen, therefore, is it's going to displace an amount of water which is equal to the volume of the sphere. So in effect, in part A, we had an amount of water in here, kind of marked by this red sort of area here. And effectively, when you put the sphere in, that's going to displace the water and effectively force it up. So if the initial water level was here, what is going to happen is that when the sphere is placed in, that's going to displace a volume of water. So it's going to force up the volume of water into this area here, this kind of yellow area here. And effectively, therefore, you've got a sort of top slice of the cylinder, which represents the volume of water that has been forced up. And that volume of water that has been forced up is going to be the same as the volume of the sphere. So in the first instance, then, we've actually got to figure out what the volume of the sphere is. And that's fairly straightforward, just using the formula that you're provided in the booklet. So the volume is going to be 4/3 pi r cubed. So that's straightforward because we know that the radius is 2.9. So if we put in that will give us an answer. So we have said that the amount of water that is forced up into this yellow area will have the same volume as the volume of the sphere. So we can we can work out that volume of the sphere, and we know that that's going to be equal to this sort of top slice of the cylinder here. And we've also got a formula for the volume of a cylinder, or this kind of yellow section here, which is going to be the cross-section area, so the base, which here is a circle, so pi times the radius of the yellow section here, which is going to be the same as the base, which is 8 centimeters. So pi times the radius squared multiplied by the height. Now, the only difficulty here is that we don't actually know this distance here. But fortunately, we know that the total height is h, and we know that the initial height of the water was 12 centimeters. So therefore, we can express this height here, the height of the yellow section, as the difference between the two. So that's going to be just h minus 12. And in effect, what we've got now then is just one unknown. So the unknown is h in this equation. And then we can just rearrange that and solve for h. And that gives us a value of 12.5 centimeters, correct to 3 significant figures.